Hello all, welcome to Basicity of Amines part 3. The link is here or in the description box. In the previous video I had spoken about toluidines. We have the aromatic ring and CH3 at various position and NH2 here with the lone pair of electron. And things that we need to remember from the previous thing is if you draw the resonance structure, the partial positive charge that we can show, and here we have NH2. Okay, I'm drawing it with the dots. So what we have to remember, there was negative charge over here, there was negative charge over here and negative charge over here. So ortho position from here, the para position from here and ortho position from here. Only these positions were having the negative charge, whereas for the meta position, it did not have the lone pair of electron. Now what will happen in these cases? This is para nitroaniline, this is meta nitroaniline, this is ortho nitroaniline, and this is aniline. Which among these four will be more basic? To come to know which is more basic, we have to remember the resonance. Here we have the benzene ring and here we have the NH2 of aniline. If you remember the resonance structure, the electron were going here, and in the resonance hybrid what we used to get is the negative charge here, negative charge here, negative charge here. So in this, what is happening? In this position there is no electron coming. So what will happen at the meta case? At the meta case, since NO2 is electron withdrawing group. So what it will do, it will try to shift the electron density from here. It will try to shift the electron density towards itself. Therefore the electron density here over here will become less. Since the electron density here becomes less, it will be less basic. Okay, so the most basic in this case will be aniline. The most basic is aniline. The reason being, all these groups, the NO2 here, NO2 here, NO2, they are electron withdrawing group. Since they are withdrawing the electron towards itself, the electron density here becomes less. And it will be less basic than the aniline. So the most basic becomes aniline because it doesn't have a electron withdrawing group. For more basic character, we need more electron density here. Okay, so aniline is the most basic. In the next case, we have to determine whether it is the para or the meta or the ortho which is more basic. Now we have to remember that second, fourth and here second position, they were having the electron. That means the meta position has no electron or very less electron density to pull towards itself. Very less electron it will pull it towards itself. Therefore this will retain the electron density on itself, and the meta will be most basic among these two. I hope you understood why it is most basic. At meta position there were no electrons. See here, the meta position, no electrons, therefore no electron density to pull towards itself. So meta is the most basic among these two. Now the next case will be, which is more basic, the para one or the ortho. Both have the capacity to pull electron towards itself, because in the resonance hybrid we have electrons at ortho and the para position, but para is more basic due to the ortho effect than the ortho this thing. So aniline is the most basic because it doesn't have electron withdrawing group on itself, then followed by meta. Meta, the reason is it doesn't have electrons in the resonance hybrid, and then comes the para, and last is the ortho. The ortho is because of the ortho effect, because they are in close proximity due to the steric effect and the electronic factors. It will be the least basic.